Hi, today we have vectors for M1 International A Level Edexcel students. We will work on some past paper questions, plus a quick summary for the vectors. Be focused. So let's see a quick summary for the points that we have here. First of all, you need to know what's the difference between a vector and scalar. So the vector, it has magnitude and direction, as we know from before, direction and magnitude. And the scalar, it has only a magnitude, and we have, for sure that we have displacement and distance. Displacement is the vector, and the scalar is just the distance. So the quantities are two types. They may be a vector, or it may be a scalar. So magnitude and direction. It's very important, the displacement, velocity, acceleration, to know their vector. And then we have how can we get the velocity? Velocity is the change or the difference happens in the displacement divided by the time. So it's the change of the distance over the time. Or you can get v is equal to u plus at if you know the acceleration and the initial velocity. Or you can get the acceleration by v minus u over t. We're going to know all of these with examples in the past papers. After some moments, we're going to see the questions. So the acceleration is v minus u all divided by t. Or acceleration can be found by differentiation. You can differentiate v with respect to t. It gives you the acceleration as well. But according to what's given in the question, you can work with the appropriate method to find the answer. And we're going to work with the main formula, which is R is equal to R node plus Vt, which is the initial position vector of any particle is moving or any object is moving. And this is the final position vector, velocity, and time. The time here is the only scalar for this question. And there is V is equal to U plus AT as well. Here, this is vector, and the time is the only scalar in this part. You need to know how do you get the magnitude as well of any vector. For example, V is equal to x in I direction plus y in j direction. So to get the magnitude for V, you need to get the square root of x squared added to y squared using Pythagoras theorem. So this is how to get the magnitude. What's I and what's j? I is the unit vector in the horizontal direction. This is I. I can be positive. If it's positive, it goes to the right, or the positive part of x-axis. If it's negative, it goes in this part of x-axis. And j is the unit vector, or the unit vertical vector, which is going upwards or downwards, because it works with the y-axis. And then we have as well F is equal to ma, force is equal to mass by acceleration. So you may work with the forces as vectors, and the acceleration, mass is the only scalar here. And you need to know how to get the resultant force when they are in equilibrium. So you can add all given forces. You add the I components to j components. If they are in equilibrium, you're going to equate it to 0 if it's in equilibrium, if it's something else. So as what I mentioned is, whenever you have forces, they are in equilibrium, so it means the resultant force must be equal to 0. So you're going to add all forces together and equate it to 0. What do I mean by adding? You're going to add I components together and equate it to 0. J components together and equate it to 0. So we're going to see different examples on these questions. So let's start with the first one from the past papers. This question says, two girls, Riyatha and Bruni, are roller coaster. They are roller skating inside a large empty building. The girls are modeled as particles, At the beginning, at time t, Agatha is at the point with position vector 11i and 11j meter, and Biruni is at the point with position vector 7i and 16j meter. The position vectors are given relative to dou O, and I and J are horizontal perpendicular unit vectors. Agatha skates with constant velocity, and here Biruni with a constant velocity. And so this is here our node for Agatha, and this is our node for Biruni. This is the velocity for Agatha, and this is the velocity for Biruni. We need to find the position vector for Agatha. So what you need to do is you need to find R is equal to R node plus VT. So it will be here. R is equal to R node at the beginning, it was 11i added to 11j for Agatha. This is R node, as it's mentioned here, plus velocity, which is 3i minus j multiplied by time t. You can expand time t there, or you cannot, or if you don't want to expand it, it's okay. You can leave it as it is, 11i plus 11j added to 3i minus j by t, or t multiplied. So it's fine if you write t before the brackets or after the brackets. So this is the position vector for Agatha. At time t 6 seconds, Agatha passes through the point P. Show that Biruni also passes through P, and find the value of t when this occurs. So after 6 seconds, Agatha, she reaches to a point P. So for example, here, if we have let's draw a quick grid to understand this point. So now, let's say Agatha is moving to this point B, or point P here, and this Biruni is moving to the same point. So both of them will meet at the same point. But let's see, after 6 seconds, Agatha, she will be where exactly? In point B, after 6 seconds. So you go replace 6 seconds or the value of t in the position vector for Agatha. So you can write position vector for Agatha, which will be here, replace 6, so it will be 11i added to 11j plus 6 multiply, if you replace time t by 6, 6 multiplied by 3, it will be 18i minus 6j. So I replace the time by 6 here. So you can collect I and I together. So it's going to be 29i plus 5j. This is the position vector for the point P, which they will meet together. And this is the position vector now for Agatha. Now we need to know that Biruni will be there after how much time. So let's get the position vector for Biruni first, and then we'll work on this. Position vector for Biruni, she starts with 7i as R node plus 16j. This is R node plus the time t by her velocity. Velocity is 4i minus 2j minus 2j. You must take a hint here to not use the time as 6 for Biruni, because it's required to know after how much time Biruni she will be at the same point where Agatha reached already. So do not use the time as 6 here. You will just find the position vector for Biruni. So we can write the position vector simply at the end as you can expand t. So 4 by t is 4ti plus 7. So it will be 7 plus 4ti in I direction, added to 16 minus 2t in j direction. This is the final form for Biruni's position vector. So once they reach to the same point, both of them, so the distance will be 0. So you can just find, you can say that the position vector for, we can write that here is the vector for Biruni, or the distance between Biruni and Agatha will be 0. So you start with the position vector of the second one, which is Biruni, minus the position vector for Agatha here, and make it equal to 0. Or you can just equate position vector for Biruni with position vector with Agatha. It's the same thing. So I will take Biruni, which is 7 plus 4t plus 16 minus 2t is equal to the new position vector for Agatha, which she reached, which is she reached 29i plus 5g. The next step is you will work on finding the value of t by equating. We just need to have some space. So you will equate these two together, the I component with I component and j component with j component. So it will be 7 plus 40 is equal to 29, and 16 minus 2t is equal to 5. Once the value of the time is equal in both of them, so it means the girl, she reached it to the point after how much time exactly. So it will be 4t is equal to 29 minus 7, which is 22. So the time will be 22 divided by 4, which is 5.5 seconds. And here it will be 16 minus 5 is equal to 2t. So 11 is equal to 2t. The time is 5.5 seconds as well. So the time now is 5.5 seconds. So the two girls, they meet at point P after 5.5 seconds. This is regarding point B. So in B, again, what did we do? We just used the time as 6 seconds. We replaced 6 in the position vector for Agatha, the first girl, where she reached to point P to know what's the position vector, the new position vector for Agatha, so which is actually replace the time here by 6. You can collect I together and j together, the components for I vector and j vector. So we had 29i plus 5j, and then we got the position vector for Biruni, which is 7 plus 4ti, 16 minus 2tj. And then once they reach the same point, the position vector for Biruni minus position vector for Agatha is 0, or you can equate the two position vectors together. So you have 7 plus 40i, 16 minus 2tj is equal to 29i plus 5j. You can equate the I components. So once you reach the value of the time, so it's correct. Let's see point C. We need to know now at time t seconds, Agatha is at the point A and Biruni is at the point B. So now they are in two different positions. So if we have the grid here, for example, and the new position vector for this one for Agatha is, for example, here, and for Biruni is here. So they are in two different places. We need to know the distance between them. So I need to know this. So here I have, this is for Agatha, for example, RA, and this is RB, for example, and this is here A, and this is B. So this will be going from A to B. So what you need to do to get the vector AB, you will go subtract the position vector for Agatha and the position vector of Biruni. You start always with the ending or the second one minus the first one. So you start with the position vector of Biruni minus the position vector of Agatha. We just got in A the position vector for Agatha. It was R is equal to, we have here 11 plus 7t in I direction here, plus we have 11 plus 16t, sorry, it's 11 plus, oh, actually it's, I just took the other position vector. So it will be 11i with 3i, t, so 3t, and here we have 11 with minus t in j direction. This is for Agatha, and for Biruni, her position vector is RB is equal to 7 plus 4 t in I direction, and we have 16 minus 2t in j direction. So now we got the two position vectors for the two girls. We just need to subtract them, RB minus RA, to get AB. So we need to have some space so we can do point D as well at the same time. So we can start writing this up there. A, B as a vector is equal to B, you can say OB minus OA, or it's position vector for Roni minus position vector for Gatha. So it will be 7 plus 4t in I direction plus 16 minus 2t in j direction minus position vector of A, which is 11 plus 3t in I, added to 11 minus t in j direction. So we need to start subtracting now I and I. So you can subtract now 7 minus 11 is 4, negative 4. And here you have 4t minus 3t is positive t. And then you subtract, here we have 16 minus 11, which will be positive 5. And then you have negative 2t minus t. So negative and negative, minus and negative will be positive, positive t. So negative 2t plus t, it will be negative t in j direction. You can just rewrite it as t minus 4 in I direction added to 5 minus t in j direction. This is AB as what's required in the question. To solve point D. So again, how did we got the point C? I got the position vector because it's after a specific, it's not mentioned at the time, it's not specific, it's general, time t, so you need to get the position vector for Agatha, position vector at time t, and then you subtract both of them. So you always, when you're required to find a distance or a vector between two different points, you get the distance. So you start with the second vector minus the first vector. So we start with the position vector of B minus position vector of A, and then we reach to this. And then it's mentioned, find the distance between the two girls when they are closest together. So when they are closest together, so there is a minimum distance. Okay, so there is a minimum distance between the two girls. So you can work now on the distance by getting the magnitude of the vector AB, because it's already the distance between the two girls. So it will be t minus 4 all squared added to 5 minus t all squared below a square root. You can keep it as like Pythagoras, d squared is equal to t minus 4 squared added to 5 minus t squared. We will try to work on finding the value of t. So once we get t, we can know the minimum distance between the two girls. So you can try to expand this. So it will be t squared plus 16 minus 8t added to 25 plus t squared minus 10t. So we can collect the like terms. It will be 2t squared minus 18t added to 41. This is d squared. So once you reach it to this is a quadratic equation, or this is the form of a quadratic equation. So how do you get the value of t? You can do completing the square, or you can differentiate the distance. You can get the turning point. We need to get the turning point to know the value of t. You can get the turning point by differentiating the distance with respect to time. So you get the first derivative, then you equate the first derivative to 0, you get the value, the critical value for t, or the stationary point, where it gives the minimum distance. So now you get t, then you go replace it. Or you can do completing square for this form. It gives you the value of t if you do completing the square, and then you go replace it. So you have two ways you can differentiate, or doing completing the square. So I will work on getting completing the square. Yeah. So I will take 2 as a common factor from the first two terms. So it will be 90 added to 41. This is d squared. So it will be here 2 multiplied by t minus 9 over 2 squared minus 9 over 2 all squared added to 41 out of the bracket. So it will be here 2 multiplied by t minus 4.5 all squared minus 20.25, and then you multiply by 2. It would be 2 multiplied by t minus 4.5 all squared minus 40.5 added to 41. So the final form can be written as, we can complete here in this part to get d. We can do it by differentiation as well. I will just do it for you after finishing completing the square. So you can simplify this expression as d squared is equal to 2 multiplied by t minus 4.5 all squared. For sure, when you have minus 40.5 added to 41, it will be plus 0.5. So the time now inside the bracket, as you know, it will be 4.5. So when you take the time as 4.5 and go replace it here, so the distance will be square root of 4.5 minus 4 all squared added to 5 minus 4.5 all squared. It gives you 0.7 meters. So how we got the value of the time? We have done completing a square for the distance to get the minimum or the value of t when the minimum distance happens. So why we're working on the minimum distance? Because it's mentioned they are closest together. So you try to think about, whenever you have a quadratic, think about getting the value of t by completing the square or differentiating the distance, the first derivative, like you're finding the stationary point or turning point, you equate the first derivative to 0, get the value of t, go replace it in the distance, and then you can get the value. If I will work on the derivative differentiation, if I don't want to work on the completing square, let's do the differentiation and see how we will get this one. So the final answer is 0.707. So to one significant rate, it's 0.7 meters. If you will work on differentiation, so you're going to differentiate the distance squared with respect to the time. So you always write here what you will differentiate, and here with respect to which variable. So we're differentiating d squared with respect to the time. So it will be 4t minus 18. Then equate the first derivative to 0. It will be 4t is equal to 18. So the time is 18 over 4, which is 4.5 as well. It's the same value. And then you go do what? You go replace the value in this distance. It will be at the end 0.7 as well. So now we're done with this question. Let's move to another one. Particle P is moving with constant acceleration at 2 p.m. The velocity of P is 3I plus 5J kilometer per hour, and at 2:30 p.m. the velocity of P is I plus 7J kilometer per hour. At time t hours after 2 p.m., P is moving in the direction of negative I plus 2J. Find the value of t. You must understand something very important. Whenever it's mentioned moving in the direction of, it means that the vector we are working with is parallel to this vector. So the vector we are working with, which is this velocity, is parallel to this one, negative I plus 2j, moving in the direction of, so it's moving in the same direction for this vector. So I will mention to you what should you do in the case of you have parallel vectors. So let's first of all try to see what we will do. Now we have the position vector or v node, and then we have which is u, and this is v after a specific time. So the time is 30 minutes, which is half 1 hour, because it started from 2 p.m. and then it's 2:30, so the time is half 1 hour. And you have u is the initial velocity is equal to 3I plus 5j. You have v, the final velocity is equal to I plus 7j. Once you have these given, you can work on the acceleration. Try to get the acceleration, which is v minus u over t. So the acceleration will be the difference between v and u. So we can now get the difference. 1 minus 3 is negative 2i, added to 7 minus 5. You are subtracting u from v. So 1 minus 3 is negative 2. 7 minus 5 is 2j, all divided by half, which is the time. So now it will be negative 4 in I direction plus 4 in j direction. This is the acceleration. Now we have the acceleration. We need to find the value of t at time t hours. P is moving in the direction of the vector negative I plus 2j. So let's get the position vector for, or let's get the vector v after a specific time t. So it will be v, it will be u plus at, or v node plus at. So now it will be v is equal to u, which is the initial, 3I plus 5j multiplied by time t, and here we have the acceleration as negative 4I plus 4j. This is the velocity now, and this velocity is moving in the direction of negative 2I plus 2j. So whenever you have two parallel vectors, you have to do this. You will take the I component for v vector over the j component of the v vector. You write them and equate it to the I component of the new vector with the j component of the new vector, and then you do cross multiplication. This is the new vector, let's call it p vector, which is this one. The one which is v is moving in direction of. So whenever you are working with two parallel vectors and it has unknown, you're going to write the I component over j component equal to the I component over j component, and then you do cross multiply and you work on the missing value. So let's apply this here. We have the value of, we have the vector, so it will be, we can just expand first, so it will be, and this v is equal to 3 minus 4t in I direction, added to 5 plus 4t in j direction. So we will write the follow 3 minus 4t over 5 plus 4t is equal to negative 1 over 2, because negative 1 here over 2 here. And then you do cross multiplication to get the value of t. So it will be 2 by 3, which is 6, minus 4 by 2. We can just write here like this. It will be 2 multiplied by 3 minus 4t is equal to negative 1 multiplied by 5 plus 4t. So it will be 6 minus 8. T is equal to negative 5 minus 4t. Collect the t's together, so it will be 6 plus 5 here, and then 8t minus 4t, so it will be 11 is equal to 4t, so t is 11 over 4, which gives, if you divide 11 by 4, it gives 2.75 seconds when it moves in the direction of this one. So the final answer is 2.75 here. And then in part B, so again, what did we do in part A? I have now the initial velocity. I have the time, which is half an hour. I have the final velocity. So I need to get the acceleration according to what's given. I get the acceleration by using A is equal to V minus U all over T. And after getting the acceleration, I can get the general vector for V. V is equal to U plus AT. So it will be V is equal to U plus T by the acceleration. So we wrote the general vector for V. And then I started comparing V as parallel to the new vector, which is, for example, let's call it P. So you write the I component over J component for the V over the I component with the J component for the P, and then cross multiply to get the value of T. To work on part B, it says another particle Q has velocity VQ. Another particle Q has velocity VQ kilometer per hour at time t hours after 2 p.m., where VQ is equal to negative 4 minus 2 ti plus mu plus 3 tj, where mu is a constant, given that there is an instant when the velocity of P is equal to the velocity of Q. So we just got now the general, or we got the main vector for the V. So let's copy it here. So this is the velocity of particle P. It was equal to 3 minus 4 T I, and we have here, it's added to 5 plus 4T and J direction. So we can now erase what we don't need here to have space to solve the last point. So let's work on this one. So now if I want to get mu, it says the velocity of P is equal to the velocity of Q. So we can equate these two together. Vp is equal to Vq. This is for part B. So you'll equate 3 minus 4T I added to 5 plus 4Tj, equated with negative 4 minus 2Ti added to mu plus 3Tj. So now we will equate. So it's better for you whenever you have more than one unknown, like here you have in the J component 5 plus 4T, and here mu plus 3T. So the time is unknown and mu is unknown as well. So try to work on the I component, equate them together to know the value of the time, and then go replace the time in the equation to get the value of mu. So what we will do is I'm going to equate the I components together to get the value of T. After how much time the two velocities will be the same. So here it will be 3 plus 4 is equal to 4T minus 2T. So it leads to 7 is equal to 2T. So time is 3.5 seconds. So after 3.5 seconds, the two particles will have the same velocity. So you can get back to the J component now. It will be 5 plus 4 multiplied by 3.5 is equal to mu added to 3 by times 3.5. We'll try to work on mu. So now 4 by 3.5, 4 plus 3.5, it gives 14, and 5, which is 19. So it will be here 19 is equal to mu, and 3 multiplied by 3.5 is equal to 10.5. So mu is equal to 19 minus 10.5, which is equal to 8.5, and this is the value of constant mu. It has no unit because it's a constant. This is regarding point B. So again, how did we do point B? It's mentioned that the velocity of P is equal to the velocity of Q after a specific time, or after time t. It wasn't mentioned any time. So you're going to take the general vector for the velocity of particle Q, and already you have the velocity vector of P at time t. So once they are equal, you equate them together. You take the component which has only one unknown, one common unknown, which is t, equate them together to get the value of t, and then you will go replace the value of t in the j component to get the value of mu. You equate the j components together, replace the value of t, you can get mu easily. Let's see one more question. Now let's move to this point. The question says the point A on horizontal playground has position vector 3i minus 2j. At time t, a girl kicks a ball from A. So here, for example, if you're working on part A, we have here's a point A on a playground where a girl, she kicks a ball at point A. The ball moves horizontally along the playground with constant velocity, 4i plus 5j. So this is the velocity, and this is the starting position vector R node. So to get the position vector for the ball, well, first what's required is we need to find the speed of the ball. To find the speed of the ball, it will be the magnitude of the velocity. So we will work on the magnitude of the velocity to get the speed. So it will be the square root of 4 squared added to 5 squared, which is root 41 meter per second. And do not write it as a decimal, just keep it in the exact form. It's better to keep it in the exact form. So it's root 41 meter per second. This for the speed of the ball. To find the position vector of the ball, we will work on getting R is equal to R node plus VT. We have R node, which is 3i minus 2j, and this one for the for the R node. So now we can work on the position vector for the ball by getting R node plus VT. So we have R node is 3i minus 2j added to 4i, which is the velocity, plus 5j multiplied by time t. This is the position vector for the ball for part B. For C, it says the point B on the playground has position vector I plus 6j. Here's point B, which is, we can write it as a column vector, 1 and 6, 1i and 6j. At time t seconds, the ball is due east of B, so it's on the east of B, so we need to know how. So due east, it means here is a change happened in the vector. So there is a change happened in I, but there is no change happened in J because it's east. So no change happens in the J component. It's mentioned that the ball is due east of B. So now this is the position vector of the ball. If you now go to the position vector of the ball at time t, is 3i minus 2j plus t multiplied by 4i plus 5j. The ball, after passing through B, it's on the east of B. So the change here, the 1 becomes 1 plus k, which we don't know exactly. It's where in the east of B, but the same value of j, there is no change happen vertically. So now, since this one, the j is constant or it didn't change, so you can equate the j component of the position vector of the ball. Position vector of the ball can be written as, let's see here, it will be written as 3 plus 4t in I added to negative 2 plus 5t in j. So now this is now the new position vector for the ball. There is no change happen in the j, okay, because it's due east of b, but there is a change happen in I. So you cannot compare now the I component with the I component because you have more than one unknown, t and k. You can work directly on the j, equate this to this, so we can know the time, after how much time the ball is due east of the point B. So it will be 5t is equal to 8. So the time is 8 over 5, which is 1.6. So whenever you are working on a point like this, and here is something is due east, so you work due east or west, so you will work on the j component. If it's due north or south, you will work with the I component because it's the one that didn't change. So this one for point C. So for point C again, what did we do? And see, the ball is due east of B, so it means it passed through B, which is 1 and 6, but there is a change happen in the I, but there is no change happen in the J. Change happen in the I, which we don't know exactly, which is K, for example. So I cannot equate the K component, I component with the I component for the ball, because there is a change happen, I cannot get the time. So, but I can equate here the j component, to get the time, to how much time the ball reached. So you can take it as a hint. Whenever there is moving in the direction of the east or the west, you will work on equating the j component to the j component with the j component with the new position vector. If you are working on the north, or the ball or the particle is due north or south of something, you can equate the I components. And in point D, it says a boy is running due east with constant speed v meter per second. At the instant when the girl kicks a ball from A, the boy is at B. So from the beginning, we can work on this. As here is point A, where the girl should start kicking the ball. Okay, and here is let's say this is B. There is a boy is start moving. Okay, he will start moving there to the east, and then after moving for some time, both of them they will intercept each other. So let's see together. The boy starts from B. So we have the position vector for the ball, which is position vector for the ball is 3 plus 4t in I, and this one here. So the position vector of the ball is 3 plus 4t in I direction, and negative 2 plus 5t in the j direction. Let's get the position vector for the boy as what was mentioned here in the question. The boy is a boy is running due east with constant speed. At the instant when the girl kicks the ball, boy is at B. So the boy started from B as R node, and then he started to move due east as it's mentioned. So he was at B, so you can use the R node, which is point B, and let's see together what will happen here. So R node is 1 and 6, 1i plus 6j. This is the position vector for point B, as it's mentioned in part C. And then the time is t multiplied by the velocity. You need to know something. The boy is moving due east with constant speed. So when he's moving due east, if the velocity is xi plus yj, this is the velocity. So if he's moving due the east, you have no j component. You have only I component, but zero j component, or you have no j component. So what you can write here on in the part of the velocity, you can write v vi, or you can write x I and 0j for the velocity. So now the position vector for the boy can be written as 1 plus x t in I direction plus here we have 0 by t. This one 0 by t is 0. So this is 6j because he's moving due east. So let's continue. Now we can work on this part. Once it's mentioned it intercepts, so both of them they meet, or the boy touches the ball, so they are at the same point now. So you can equate the two position vectors, 3 plus 4t in I direction plus negative 2 plus 5t in the j direction is equal to 1 plus xt or vt in I plus 6j. You can work on the time where both of them will be due east by equating the j component, because you cannot equate the I components together because you have more than one unknown. It's mentioned that the boy and the ball intercept, so they meet each other. Yeah, like this. So this is the point where both of them they meet. So you can equate the two vectors, two position vectors for both of them. So go get the time first. You will equate negative 2 plus 5t with 6. So 5t is equal to 8. So the time where they meet due east of B, it's 8 over 5, which is 1.6 seconds. And then you can work on finding the value of the velocity. You go now replace, you can equate now the I components together. X here, it represents the velocity. So it will be 3 plus 4 by 1.6 is equal to 1 plus x by 1.6. So it can be 4 by 1.6 added to 3. It gives 6.4, and 3, it will be 9.4 is equal to 1 plus x by 1.6. So it will be 8.4 if you shift the 1 there. So it will be here is equal to 1.6x. So x is 8.4 over 1.6, which gives you the velocity 8.4 divided by 1.6. It gives 5.25 meter per second. So now the final, or the velocity for the boy as a scalar is equal to 5.25 meter per second. This is the final answer. So again, how did we get point D? The boy and the ball, they will intercept due east of B. So we have the main position vector for the ball, and the boy, the position vector is when the boy starts from B and moves due east of B. So he starts from B, so B is the R node for the position vector of the boy. So B is 1 and 1i 6j, which is R node. the time is unknown, and here the velocity, since he's moving due east, so there is a component for I, but no component for J. So here you can get the position vector of the boy by collecting the i's together. So t by x is tx plus 1, so it's 1 plus xti, 6j and 0j, 0tj, it will be 0, so 6j only. This is the position vector of the boy, position vector of the ball. Equate them because they intercept or they meet at the same point. So you equate them, and then you equate the j with j because it's moving due east, as we said before. You take the j component, equate them to get the time. After how much time they will, both of them will be at or intercept due east of b, and then you need to equate the I component and I component to get the velocity, replace the value of the time, and then try to make x, or get the value of x, which is the velocity due east, which is 5.25. Let's move to one more question. At time t is equal to 0, a bird A leaves its nest that's located at the point with position vector 20i minus, here we have this. Let's underline the givens. So we have at time t0, this is our node for bird A, and flies this constant velocity negative 6i plus 7j. This is the velocity for bird A. At the same time, a second bird B leaves its nest and which is located at the point with position vector negative 8i and 9j meter, and flies with velocity pi plus 2pj meter per second, where p is a constant at time 4 seconds. Bird A is southwest of bird. Bird B is southwest of bird A. We need to find the direction of motion and part A. Find the direction of motion of A, giving an answer as a bearing to the nearest degree. So let's see the part here. If I have a grid, for example, we need to know the angle for bird A. Bird A is negative 6. So we can just make it like this. Negative 6i and 7j. Then you close this right angle triangle. So here is the vector. This is the vector that we are working with. This is vector. This is the velocity or the direction of motion for this bird. So this is negative 6 here, and here is 7. So you need to get theta. To get the bearing for the bird, what you will do is you will get complete bearing. So you can make 270 added to theta. Once you get theta, you will add 270 degrees, because here is first quadrant 90, second quadrant 90, third quadrant 90. So 270 added to theta to get the bearing, because you know the bearing is this is opposite and this is adjacent, so it's 7/6 that gives the angle. And by the way, why we didn't write it's 49.3, which is approximately 49, because it's required to the nearest degree. So now why did I use 7/6, not 7/-6? Because I need to get the original angle theta, which is acute. So I will not consider the negative sign here, because I need to get the acute angle theta. So it's 49. If I want to get the bearing, I'm going to make 49 added to 270 degrees. It gives me the bearing for motion of direction of motion for bird A. So to the 49 added to 270 degrees, it gives the final answer is 319 degrees. So 319 degrees. This is the bearing for bird A, because we took the first 3 quadrants adding the theta, so it gives the whole bearing for or the direction of motion as a bearing. It will be this angle, all of this angle. Okay, so let's move to find the speed of bird B. When we're working on part B, you need to read very carefully the first part of the question. First part of the question says, to get part B, you need to read the question carefully. The question says, whenever we need to find the position vector for bird A and position vector for bird B. So it will be as follows: R node plus R node, which is here, it's 20i minus 17j added to t multiplied by negative 6 plus negative 6i plus 7j, and here we have RB, which is negative 8i added to 9j plus t multiplied by the velocity, which is pi plus 2pj. Here it's mentioned after 4 seconds, so let's write RA. We'll collect the i's together, so it will be 20 minus 6t in I direction added to negative 17 plus 7t in j direction. Our position vector of v is negative 8 plus pt and I added to 9 plus 2pt and the j direction. So now it's mentioned after 4 seconds. So let's see position vector of A after 4 seconds. So we replace the time by 4. So it will be 6 by 4 is 24. So 20 minus 24 will be negative 4i added to 7 by 4 is 28. 28 minus it will be 11. 11j. I need to write the brackets. So this is the position vector of A. The position vector of B is you replace now the time by 4. So it will be negative 8 plus 4p in the I direction added to 9 plus 4 by 2. Here 4 by 2 is 8p, and this is in j direction. You need to notice something. Now this is the position vector of A. Position vector of A here, which is negative 4 and 11. Negative 4 and 11. So this is now the position vector of A. But B is in southwest. So if this is the west and this is the south, so V is here exactly. This is position vector of V. This is RA and RB. So we need to get the vector RB minus RA, or if you want to go from RA to RB, you will move a distance horizontally and distance vertically, which is equal. So you go get first the difference between the two vectors, RA and RB. So I will go subtract these together. So it will be RB minus RA. As I told you before, we start always with the second one. So it will be negative 8 plus 4p minus 4. So it will be negative 8 plus 4p minus negative 4, which is plus 4 in the I direction, added to 9 plus 8p minus 11. So 9 plus 8p minus 11. This is in the J direction. So you must notice something. Now we got this vector, which is the distance between, or the displacement between RA and RB. But you must notice something. Now bird B is in southwest of A. So we move here. We moved the same distance since it's southwest. So you move a distance horizontally that's equal to a distance vertically. So this vector, which is AB, the difference between RB minus RA, now you can write it as here, negative 4 plus 4pi added to 8 minus 9 minus, it will be negative 2 plus 8p and the j. You will go now equate the two components. I component is equal to the j component. Why is it equal? Because the distance you moved horizontally, the same as the distance you moved vertically. Whenever it's mentioned southwest or the northeast, or it's mentioned like here, like for example, northwest, or it's mentioned southeast, these directions all are equal because it comes in the 45 degrees angle. So it's exactly, you're moving the same distance here, horizontally, then vertically, or vertically, then horizontally. So they are equal. So the components of the vector AB, which is the difference between position vector of the bird B minus position vector of bird A, the I component must be equal to the J component. So you will go equate this to get the value of B. So what I will do is, I will go equate now this part together. So it will be negative 4 plus 4p is equal to negative 2 plus 8p. So you shift, you will go shift this, it will be negative 4 plus 2 is equal to, we have here 8p minus 4p, so it will be 4p is equal to negative 2, so the p is equal to negative half. So p now is equal to negative 0.5. We need to find the speed of B, speed which is the magnitude of the velocity. We already know the velocity of bird B, so you can replace the value of P here, and then you get the magnitude. So the velocity for B is equal to negative 0.5 I plus 2 by negative 0.5 is negative 1, so it can be minus 1 directly for J. If you want to get the speed, it will be the magnitude of the velocity of B. So it will be square root of negative 0.5 squared added to negative 1 squared, and all of this below the root. You can just get it from the calculator. It will be negative 0.5 all squared added to negative 1 squared below the root. It gives you root 5 over 2 or 1.1. So it's root 5 over 2 or it's 1.1 meter per second. So this is the speed for bird B. So again, how did we do point B? Because it has 10 marks, it's a bit lengthy. So you need to get the position vector for bird A first by using the initial position vector, which is R node, and you have the velocity. So it will be it will be r node plus t multiplied by velocity. The same thing we have done for bird B, which is r node plus t multiplied by the velocity. And then we collected the I components together, like this here. And then I replaced the time by 4 as it's given here after 4 seconds. So this is the position vector of A after 4 seconds, position vector of B after 4 seconds. You need to know the distance or the displacement between them. So you're going to subtract second minus first. So this is the direction or the vector as a displacement between them. But it's southwest. So it means moving horizontally, the same as moving vertically. They are two equal distances. It's like an isosceles triangle. So it means the I component for the vector AB, or this displacement for this displacement here, it's equal, the I component is equal to the J component. So after you got the I component and J component of AB, you can equate them together, work on finding the value of P. You got the value of P. It's required to find the speed of bird B. So after you got now the value of P, go replace it in the velocity of the bird B. So it gives you negative 0.5 I minus 1J. Go get the magnitude because the speed is the magnitude of the velocity. So it will be square root of negative 0.5 squared plus negative 1 squared. It will be root 5 over 2 or 1.1 meter per second. This is regarding this question. Let's move to one more question. At 7 a.m., it's mentioned here, at 7 a.m., a ship leaves a port and moves with constant velocity. The position vector of the port is negative 2i plus 9j. So the initial position vector is negative 2i plus 9j. At 7:36 a.m., the ship is at the point with position vector 4i plus 6j kilometer. So now we have time and we have the final position vector. We need to find the velocity. So now what you will do is for part A is equal to, we have here the final position vector is equal to the initial position vector added to velocity by time. And you need to work on this part. And the final position vector or the initial position vector is negative 2i added to 9j, this one here, added to the velocity, which we don't know, multiplied by the time. Now the time, you must get the time into hours. So there is a difference of 36 minutes. So you go divide 36 by 60 to know exactly the time as hours. So 36 divided by 60, it gives 0.6. So 0.6 hour, this is the time. So it will be multiplied by 0.6. It gives the final position vector, which is 4i plus 6j. Yeah. So you just like are working on an equation. So you will shift this to the other side by different sign. So it will be 4 minus negative 2. It will be 6i. And then you have, this will go negative. So 6 minus 9, it will be negative 3j is equal to 0.6 v. So v is equal to 6 over 0.6 and I added to or subtracted from minus 3 over 0.6 j. This gives you the final answer. So it will be 10 in I direction minus 5 in j direction. This is the velocity for the ship. So now let's see point B. You're asked to find the position vector. You're asked to find the position vector of the ship after t hours of leaving the port. So the ship now, R node is equal to R is equal to R node plus VT. So it will be R node is equal to here. R node is 2, -2 plus -2I plus 9J added to the velocity, which we got here, 10I minus 5J multiplied by the time T, and just keep it as it is. This is the main position vector for the ship. What we'll do in part C is, part C that talks about two different situations. At time 8:48 a.m., passenger on the ship notices that the lighthouse is due east of the ship. So let's say we have a grid here, and let's imagine this the ship is moving in this vector, and it sees, let's make it a bit small, and the passenger sees that here the lighthouse is due east of the ship. So if here is the ship and this is the lighthouse, so it's due east here. This is the lighthouse. Okay, it's L. This is the lighthouse. And then when it continues and the time it changes, it becomes, the same passenger, he sees the lighthouse is due, as you see here, due northeast. So here we can, this is the position vector for L. This is the position vector for L that comes from O, and this is the position vector of S when the time was 8:48. Then when the time becomes 9, this is the SL, and the position vector remains the same, no change. So what we will do is we'll do the first situation as follow. It will be like this. We will consider the position vector of the lighthouse, or we can just call it RL, for the position vector of the lighthouse is equal to xi plus yj. Let's get the displacement, which is here, this one, the vector SL. This is the vector SL, the ship and the lighthouse. It will be SL will be the difference between the lighthouse minus the position vector of the ship, or you can call it RL minus RS. So it will be as follows. We just assume that the position vector for the lighthouse is xi plus yj, added to the position vector of the ship is -2i plus 9j, and here we can write this as a column vector. It's the same thing. So it will be x and y, yeah, minus, this would be written as -2 plus 10t, -2 added to 10t, and we have here 9 minus 5t. This is SL. So now at time, when the time is it's 8:48. So now if you get the difference, you're gonna find it's 1 hour and 48 minutes. So it's 60 and 48, which is 108 minutes. If you change it into hours, it will be 108 over 60. It gives 1.8. So it's 1.8 hours. So we can say the time is 1.8 hours here. So you need to change the time into minutes. So it becomes, as into hours, sorry, it's 1.8. So now you will go replace. So SL is equal to you replace here this, it will be x, and here y. So if you replace this by 1.8, so 10 by 1.8 is 18. 18 added to -2, it's 16. So it's x minus 16, yeah? And then down that's 5 by 1.8, it's 9. So 9 minus 9 is 0. So it will be y minus 0. And it's already mentioned as due east. So since it's mentioned due east, so y is equal to 0. So now we got the value of y. Let's move to the second situation when the ship moved more and the time becomes 9. Now the passenger can see that the ship or the lighthouse is on northeast from the ship. So now this is the SL, but after the time it changes. So now the time is 2 hours because it's now 9. So difference 2 hours. So we can go get SL, but take in consideration that y is 0. So you will go replace the time by 2, or you can just open this one. It will be multiplied by 2. 10 by 2 is 20. 20 minus 2 is 18. So it will be x minus 18 here. And then it will be 5 by 2, which is 10. So 9 minus 10 is -1. By negative, it's +1. So now it's x minus 18 and 1 here. This is the vector between, or this is the displacement between the lighthouse, but it was mentioned that it's northeast of the ship. So if I'm at the ship and I want to go to the lighthouse, so I will move north and then east. And northeast, as you know, it's the 45 degrees vector, which means the I and j component are the same. I and j component are the same. So you can equate both of them to each other. So you can equate the I component, which is, sorry, we need to reverse. This is the j and this is the I. Here is I. So you need to equate the two components, x minus 18 equated to the 1 here. So it will be x minus 18 is equal to 1. So now x is equal to 18. And this is I component. It's equal to 19. It equals to 19. So now the position vector for the lighthouse, which is RL, is 19I. So the position vector is exactly 19I. So how did we get this again? We used the two situations. The first situation on the time was 1.8 hours. We assume that this is x and y, the position vector for the lighthouse, and this is the position vector of the ship. We substituted the value, or we replaced the value of t here in the equation, and then we got x minus 16 and y minus 0, and since it's due east, so y is 0. So after 2 hours, it will be, you go replace the value of t by 2, so -2 plus 10 by 2, it gives -18, or it gives 18, and here it gives -1, so it will be x minus 18, and the y is 0 because it's due east. 0 minus 1 minus -1, it will be 0 plus 1. So now the vector or the displacement between the ship and the lighthouse is x minus 18 and 0 and 1, but this is due northeast. So northeast, to go from the ship to the lighthouse, you will move vertical, horizontal, so both of them are equal, and northeast, southwest, and all of these directions are equal. So you can equate the position vector or the I component with the j component, so it becomes 19I. So now the position vector for the lighthouse is 19I. In point D, it says, so now the situation has been reversed for question of a point D. In D, we can do this point, and point D, it says the position vector of the ship when it's due south of the lighthouse. So now we need to get the position vector of the ship when it's on the direction or it's south of the lighthouse. So now the situation is reversed. It was SL before because I was observing the lighthouse from the ship, or the passenger was looking at the lighthouse from the ship. So now the situation has been reversed. It's LS. So it's the position vector of the ship minus the position vector of the lighthouse. Position vector of the ship is -2 plus 10t, and here we have 9 minus 5t minus, this is, as you know, 19 and 0. This is the lighthouse position vector. So now you can do what? Since it's due south, so we can equate, as I told you before in the previous questions, it's due south, so you can work on the I component. This is J component, so you'll work on the I component. You equate now the I component to the I component to know the time the ship took till it reaches to the south of the lighthouse. So it will be 10t is equal to 21. So the time the ship took is 2.1 hours to be in the south of the lighthouse. So it's 2.1. So now to get the ship position vector, you will go replace RS. You will go replace now. It's -2 plus 10 multiplied by 2.1. And then 9 minus 5 by 2.1. You'll again notice that there is no change happen in the I component because it's due south. So the change will be only in the J component. So here it will be 10 by 2.1, which is 21 minus 2, which is 19 here, and then 5 by 2.1, 5 by 2.1 equals 11, 10.5, 10.5, 9 minus 10.5, it's 1.5. So the position vector for the ship now is 19I minus 1.5J. If you go compare between the position vector for the lighthouse and point C, it was 19I, and now the lighthouse or the position vector of the ship is 19 and -1.5. So it's due south of the lighthouse because negative part of J. Let's move to one more question. This question for Jan 2022 exam. It says a ship A moves with constant velocity 3I minus 10J kilometer per hour. At time t hours, the position vector of A is R kilometer. At time t, A is at the point with position vector 13I plus 5J. So now we have the position vector for ship A. This is the initial position vector, and here's the velocity. So we need to find R. To get R is equal to R node plus VT. So it will be as follow. R node is equal to R node here is 13I plus 5J added to velocity, which is 13I minus 10J multiplied by the time. So this is the position vector for the ship. The R node, we have the initial position vector, the initial and the velocity, and here's the time. Another ship B moves towards constant velocity 15I and 14J at time t, position vector 3I minus 5J. Show that the time at time t hours AB is equal to 12t minus 10I plus 24t minus 10J. So on point B, if we have this part in here, if the ship A is moving in this direction, for example, and ship B is moving in this direction, and we need to get the distance, this is the displacement, and here the ship A, here is ship B. To get the vector AB, so you will do, this is for point B, to get the position vector. So AB is equal to RB minus R of A. We don't have the position vector for B, so let's get the position vector for B first. So the position vector for ship B is position vector for ship B is equal to, we have the initial position vector 3i minus 5g, and here's the velocity, so it will be 3i minus 5j, and here added to, we have time multiplied by 15i plus 14j. So we can just write it as 3 plus 15t in the I direction, added to negative 5 plus 14t and the j direction, and this is RV. And we already have RA, so we can simplify it or write it in the same form here. We can write that RA is equal to, here we have 13 plus 3t in the I direction, added to 5 minus 10t in the j direction. So to get AB, as we said up there, it will be as follow. So now to get the position or the vector AB, you would go subtract the position vector of ship B minus the position vector of ship A. So it will be 3 plus 15t minus 13 plus 3t. So it will be here. We have 10, negative 10 here, and it's 12t in I direction, added to, here negative 5 minus 5, it will be negative 10, and here we have 24t. This is in the j direction. If we want to write it as what's given here, you can write 12t first minus 10 in the I direction, and here it will be 24t minus 10 in the j direction, and this is A, B. So it was 12t minus 10 added to 24t minus 10. And this is the vector AB. Then it's given in point C, it says, given that the two ships do not change course, so it means they did not change their directions, find the shortest distance between the two ships. So whenever you are required to find shortest distance, or the two ships are closest together, or they are very close to each other, all of these words, they are keywords for using the completing square formula or differentiating the distance, as the question we have done before in this video. So we can now, to get the distance for part C, it will be the magnitude of vector AB. This is the distance. So it will be the magnitude, which is squaring 12t minus 10 added to the square of 24t minus 10. This is the distance, so we can, but it's supposed to be below square root. So if we're gonna square this, it will be written as 12t minus 10 squared added to 24t minus 10 squared. And then we can just erase what did we write here and and part B. So we can work now on part C. So now we got the distance here. So the distance squared will be, so you need to split or expand the bracket, so it will be 144t squared, and here it will be plus 100, and then it will be minus 240t added to, we have 24 squared is 576 t squared, and here we have plus 100, and then we have in the middle it's minus 480 t, and then you can collect the like terms. 576 added to 144, it gives 720 t squared, and you have 480 added to 240, it gives 720 as well. 720 t, and here plus 200. This is the squared. So you can do the thing that we have done in the first question. You can use either completing the square or differentiation to differentiate and get the stationary point to know the value of t, to get the first derivative, and then equate it to 0 to know the value of t. And then after you got the value of t, you go replace it in the distance here to know what's the shortest distance between the two ships. So I will use differentiation here, so it will be the derivative of d squared over dt. Differentiation of the distance squared with respect to time, so it will be 2 by 720 gives 1440 t, and plus supposed to be here, this is supposed to be negative 720 because negative 240, I have here negative 240 and negative 480, it makes negative 720, so it's supposed to be negative, not positive, because we cannot have a negative value for the time, so it will be negative 720. Then equate the first derivative to 0 to get the stationary point, or the point that gives you the smallest, the minimum value, so it will be 1440 t minus 720 is equal to 0. So t is 720 over 1440 gives half. So the value of the time now is half, which the distance will be the shortest. So to get the distance now, that will be the square root of 12 by half minus 10 all squared added to 24 by half minus 10 all squared. So it will be root 20. And then you can know the value is 2 root 5 or 4.4. It's 2 root 5 or it's 4.47 kilometers. This is the shortest distance. So once again, what do you do in this part? You will get the distance, which is the magnitude for this vector, and then you can square it to remove the square root, expand the brackets, try to get the equation. It's quadratic equation. Once you reach to the quadratic equation, you have two ways or two methods. You can do either completing the square for this form, and when you reach to the completing square form, which is a multiplied by t plus b all squared plus c, this is the value of the time, which is here. You just change the sign, so this is the time value, and then you go replace it in the distance here. Or you can do differentiation as what we have done to get the smallest value or the shortest distance. You need to know what's the time that have been taken to make the two ships. They are in a very short distance between each other. This is regarding point C. For point D, we need to solve point D now. D, it says find the bearing of ship B from ship A. Ships are closest. Now, when they are very close to each other, what was the time to make them very close to each other? So the time was half 1 hour. So now we go replace half in the vector AB to know the bearing. So it will be 12 by half, which is 6. 6 minus this will be negative 4i added to 12 by half, which is 24 by half, which is 12. 12 minus this, it will be 2j. So we need to know the bearing when the two ships are closest. So it was, this is ship A and this is ship B when they came very close to each other, and this is vector. By the way, it's not a main condition that they become like this. So this is the vector between them. So I need to know the bearing. Yeah, this is ship A, this is ship B. So I need to know the bearing when they are close to each other. So I will try to get this angle, which is theta, and then I will make 90 minus. So let's see on the grid how this vector will be represented. It will be negative 4i and then 2j. So it will be in the second quadrant. So if I get this angle, here it's negative 4 and here is 2. If I get this angle, I will add 270 degrees to this angle, or I will make 360 minus. If I get this angle, it will be 360 minus. If I get this angle, it will be 270 plus. So you will do as follow: tan inverse for 2 over 4, which is half. So it will give you theta. And I said before, we cannot, or it's preferred not to use the negative sign here to get the acute angle itself. So it will be 2 over 4, which is half. So we can get the tan inverse for half. It equals to 26.6 plus 270, 26.6. So the bearing is 26.6 added to 270. It gives now 296.5. So 196.5, or we can say 297 approximately. This is the bearing on the ships. The two ships, they are very close to each other.